Welcome back to Stewart Science. Last time we talked about how atoms break down with alpha and beta decay, and today we're talking about the rate that they break down. Now, this rate will help us figure out how old artifacts are. So if you had a fossil or a book and you wanted to know, is this book from 1950 or is it from 1850? Or if you want to know, is this fossil from 2,000 years ago or from 200,000 years ago or from 200 million years ago, what you would do is look really closely at the radioactive atoms inside that, and you would be able to tell, based on how many of those radioactive atoms are still there, how old the sample is. Because every atom breaks down in this graph shape. This is called an exponential decay. The only difference is how long it takes for that atom to break down. Some atoms break down quickly, some atoms break down slowly over billions of years, and so different atoms break down at different speeds, but they all make this shape. So if you can figure out at what speed the atom is breaking down, you can figure out how old the sample is very easily. And so they all make this shape. We call the time that it takes, I'll write it down here. If you're a note taker, you should write this down too. The time it takes for half of your atoms to break down. That's called a half-life, and it's different for every atom. Some isotopes break down in 10 seconds and they're gone. Some isotopes break down in 10 billion years. And so if you had a rock that was made 10 billion years ago, if you looked at it, it would have half of those atoms left. That's what a half-life is. So if you look at this graph here on my right, on your left, when I get to 50% of the atoms remaining, that's one half-life. If another, let's say that's 5,000 years, if 5,000 more years go by, now we've got half of that left, and half of a half is a quarter. So if my half-life is 5,000 years, this would be 10,000 years. It took me 5,000 to get to halfway. It takes me 5,000 more to get halfway again, which is 25%. And this keeps going. After another half-life, now we're at about 12% or 1/8. And then after another half-life, we're at about 6% or 1/16. I'm not going to give you any more than that because at that point it gets a little bit difficult to accurately measure how much is there, because you can see there's really close to zero here, these last few steps. So I'm going to say out to about 4 half-lives is where I'm going to want you to be able to work with. So let me summarize here. After 1 half-life, you will have half your atoms broken down and half of them left. That's what it means. However long that time is, if it's 5,000 years, after 5,000 years, then half your atoms are left. That's 1 half-life. And it leaves you with 1/2 of your atoms left. You're here on the graph. After 2, you have half of those left. So half of a half is 1/4. That would be 2 half-lives. After another half-life, so another 5,000 years goes by, then you're down to 1/8. That's 3 half-lives. And then if one more goes by, you're down to 1/16. You're down to 4 half-lives. Scientists could probably keep going a little bit from that, but that's where we're going to stop. So 1 half-life is 1/2 of your atoms left. That's the definition of a half-life. 2 half-lives is 1/4, 3 is 1/8, 4 is 1/16. So the way this works is that if each half-life is 5.27 years, if you know what fraction is left, you can figure out how old the sample is. So let's say I was down to 25% left. I'm down to 1/4. I know that 1/4 from that last slide is 2 half-lives. And if each one of those is 5.27 years, then I'm going to have 5.27 times 2. So 5.27 times 2 is 10.54 years. So if a detective found a body in the wilderness and they found some bones and they ran those bones through their little laser beams and they could figure out how much of these cobalt-60 atoms were still in it, and they found that there was 1/4 left, they know that that skeleton has been in the woods for 10 years. That's how this science works. If you know the half-life, you can figure out the age. We'll do some examples here. Let's say you were down to 1/8 of your sample remaining, and each half-life is 200 years. 2 questions. 1, how many half-lives have gone by? That's just matching up our fraction to our graph. And 2, how old is our sample? Well, if we have 1/8 left, that's half of a half of a half. 3 half-lives. If each one takes 200 years, 3 times 200 is 600 years. So we know that that suit of armor that we're looking at was made in the 1400s because we have all this science to back it up. So all you need to do is match up the fraction 1/8, 1/4, 1/16, or 1/2 to how many half-lives it is, and then multiply that number by how long one half-life would be. Let's try another one. Let's say I had a half-life of 30 million years. And my sample has 1/16 of those atoms left. I want to know how many half-lives and how old is the sample. Well, when we go back to those 4 things that we wrote down a minute ago, 1/16 is 4 half-lives. So my answer, how many half-lives, is 4. If each one takes 30 million years, 30 times 4 would be 30 times 4, 120 million years. I may ask you to do this question in reverse. So I might say, let's say one half-life is 6,000 years. I might say, if you think it's 12,000 years old, one, how many half-lives, and 2, what fraction of your atoms should be left if that was the case. And so the first thing you have to do is to find your number of half-lives, divide your time by how long each half-life is. And you get 2. If 2 half-lives have gone by, that means it's been cut in half twice. 1 would be a half, 2 would be half of that. Half of a half is 1/4. So this would be 2 half-lives, and you should see 1/4 of your atoms left. I'll do one more example like this. Let's say that you had a half-life of 3 million. I'll write it out actually. Million years. And you found a fossil that you thought was 12 million years old. You take your 3 million and divide it by your 12 million. Take your age, divide it by your half-lives, and that's going to give you 4. If 4 half-lives have gone by, that's half of a half of a half of a half, which would be 1/16 of your atoms remaining. And that's how to do half-lives. As always, this is Mr. Stewart. Keep learning no matter what.